Okay, hello everyone. So in this video, we're asked to use the closure property specifically to prove that the language L, where L is ANBN, for n greater or equal to 335, is not regular. And so this is an aside, but this is kind of a shout out to a class I used to TA at Concordia, known as Comp 335. And so that was the course for theoretical computer science at Concordia, where I first started TAing this class, actually. But none of you probably care about that. So let's just move on. Okay, so we're asked to use the closure properties here to prove that this language is not regular. So you could have used the pumping lemma, right? You could have used the pumping lemma. But I think one trap students typically fall into when they try to use the pumping lemma for something like this is they say, okay, well, the opponent picks m, right, which is a positive integer, okay, and then they pick w, a, m, b, m, right, and then they say m greater or equal to 335. But this is definitely incorrect, right? This is definitely wrong. And it's wrong for one particular reason, that if you assume m is greater or equal to 335, that means what you're really doing is you're kind of forcing your opponent to pick a certain value for m, right? And so what that means is that at that point, m is no longer arbitrary. It is no longer arbitrary, right? So you cannot assume this, right? Because what if m is not greater or equal to 335? Your opponent is allowed to do that, right? Your opponent is allowed to do that. But then if it isn't greater or equal to 335, your string is no longer in L. And so already at this point, you've not followed the rules of the game, and so already you lose, right? And so for this pumping lemma proof to be correct, instead what you would probably need to do is you probably need to do something like, oh, instead I pick w is a m plus 335, b m plus 335, right? So this means that now m can be anything, and the way you pick your string means that m being anything is not a problem for your string w, right? And then from there, you can pump up or down, and it doesn't really matter anymore. It does matter how you pump, well, more or less, right? But essentially what I'm trying to say is that this restriction no longer needs to be made, because now you've guaranteed that this condition, right? That's what I was trying to say. This condition, this predicate condition in your language is satisfied, because you know this tells you that you have at least 335 A's and B's, okay? And then M is just so that the length of W is greater or equal to M, right? Okay, but that's not how we're going to do this proof. What we're going to do is we're just going to use the closure properties, okay? So how are we going to do that? Well, we're going to suppose that L is regular. Okay, so we suppose L is regular. And now let's set F to a new language. F is going to be the language ANBN, where n is at most 335. Okay? Or not at most, it's strictly less than 335. All right? So of course n is greater or equal to 0, because what does it mean to have a negative exponent? It doesn't mean anything, right? So this is the language F, right? F is a finite language. It's a finite language. Why is it finite? Because it has 335 possible strings, right? It has A0, B0, A1, B2, all the way to A334, B334, right? So if you count this properly, this has 335 elements, right? So that's definitely finite. And we know that finite languages are regular. So finite language is a regular language. If you don't know why, or if you don't see why immediately, you can look back at one of the exercises I did on NFAs and closure properties, and you'll quickly see why this has to be true, right? And so I have F, which is actually a regular language. Now what happens if I take L and I union it with F, right? So L contains all strings of the form AN BN for n greater or equal to 335. And F contains really the complement of L in terms of, right, so not quite the complement. So F is not quite L complement. You could say that F is L complement intersect L A star B star, right? And so, I mean, this fact is less important. It's just maybe important to realize that it's not the complement exactly and why, right? So that is probably good for you to understand. So make sure you see why F is not equal to L complement, okay? But for the purposes of what we're trying to prove, the only thing we really need to know is that, well, L contains A and Bn. L contains strings of the form A and Bn for n greater or equal to 335, and F contains the strings of the form A and Bn for n at most 334. And so their union is AN Bn for n greater or equal to 0, right? But because we assumed that this guy was regular, and we assumed that this guy was regular, and regular languages are closed under the union, it must mean that this language is also regular, right? And so that means that we have the conclusion, the incorrect conclusion, that AN BN for n greater or equal to 0 is regular. And so that's clearly false. We have a contradiction. Which means that our initial assumption that L was regular was incorrect. So that means that L is not regular. Okay, and that's how you could use the closure properties to prove that this language is not regular.